Hello students, this is lecture number 5 and in this lecture we will study what means the linear differential equation and how to solve the given linear differential equation. So firstly we will see what is the definition for the linear differential equation. So any differential equation in which the dependent variable is of linear degree, linear means what? Of degree, or is of degree 1, degree equal to 1, then we say it as linear differential equation. Okay, so if I will write it here, dy by dx, okay, in this case this y and x are variable, but this y is called dependent variable because it is depend on x, and this x is called independent variable. Okay, so any differential equation which is of order 1, also the degree 1, and also if this dependent variable is of the linear degree or of the degree 1, then we will say that the given differential equation is linear differential equation. Okay, for example, I will write it as dy by dx plus x into y equal to sin x. Now clearly the dependent variable is y, and wherever the y is there, its degree is 1, so that's why it is a linear differential equation. Okay, so basically there are two types of linear differential equation. Okay, there are two types of linear differential equation. Okay, so first one is the linear differential equation of the type dy by dx plus p into y equal to q. Okay, where this p and q are functions of x alone, or those will be constants. Okay, so this is one of the type of linear differential equation, and the other type of linear differential equation, that is number 2, is dx by dy plus p dash into x is equal to q dash. Okay, where this p dash and q dash are functions of y alone, or constants. Okay, then these are called the linear differential equation. Now see, in the first type, this is the first type linear differential equation. It is linear because the dependent variable is y and its degree is 1, then we will say it is a linear differential equation. But here the dependent variable is y, that's why we will say this differential equation as linear in y, this as linear in y. And if you will observe, in this second type of linear differential equation, the dependent variable is x and its degree is x everywhere. Okay, so that is why we will say this is a linear differential equation, but we will say this is linear in x. Okay, so it is completely depend on whether the linear differential equation is linear in y or whether it is a linear in x. Then we will solve its solution, or we will find its solution depending on in what variable it is linear. Okay, so firstly, in the first case, if it is linear in y, then we can find its solution. Okay, so before finding the solution, now you need to observe what are this p and q and what are this p dash and q dash. Okay, so what are p and q? P and q are functions of x alone, or those will be constants. Okay, those may be functions of x alone, or those will be constant. And in this case, this p dash and q dash are functions of y alone, or those will be constants. Okay, now if we have the linear differential equation in type 1, then we can find its solution. So before finding solution, you need to find its integrating factor. Okay, so integrating factor of such a linear differential equation which is in y will be, integrating factor is equal to e to the power integration p dx. Okay, where is this p taken from? This p is taken from this term. Okay, so you need to integrate this p with respect to x. Okay, and that is in the power of e, so that will be your integrating factor. And once you will get the integrating factor, you can write its solution clearly. Then the solution of such a linear differential equation will be y, okay, into integrating factor. I will say this as I, this is equal to, suppose I, y into integrating factor equal to integration integrating factor into q. Where is this q taken from? It is taken from this term which is at the RHS of the given linear differential equation, and integrate it with respect to x plus constant. Okay, so if you have the linear differential equation in y, then this will be its solution. Okay, and what the solution contains? It contains this integrating factor, and that integrating factor will be calculated from this term, from this equation. Okay, suppose in the second type you have the linear differential equation in type 2. Okay, suppose it is in type 2. Type 2 means what? Suppose it is linear in x, means what? If you will see the example, the dependent variable is x in this case, and it is linear everywhere. That's why we will say it is a linear differential equation in x. And here you can see this p dash and q dash are nothing but the functions of y or constant. So if you have the linear differential equation in x, then also we find the integrating factor. Okay, so its integrating factor will be equal to e to the power integration p dash dy. Okay, this will be its integrating factor. I will say this as I. Then its solution will be given by x into integrating factor equal to integrating factor into q dash dy plus constant. Okay, now those will be two types of solution for our linear differential equation, depending on whether this the given differential equation is given linear in x or whether it is given linear in y. Okay, so this is how we will solve the linear differential equation. Okay, for example, we have this linear differential equation. Okay, this is our linear differential equation. Now we need to check whether this is linear in x or linear in y. Okay, so you know, in both the cases the coefficient of dy by dx is 1, so we will try and make it 1 just by dividing whatever the term is here to the whole equation. Okay, so divide this whole equation, divide equation by what? 1 plus x square. So what will happen? What we will get? This will be dy by dx plus 1 upon 1 plus x square into y equal to e to the power minus tan inverse of x upon 1 plus x square. Okay, now you can clearly see, if you will compare this to our general form of linear differential equation in y, general form of linear differential equation in y is dy by dx plus p into y is equal to q. Okay, if we will compare, this p and q are functions of x, and in this equation also this y is multiplied this term and it is a function of x, and this whole term is a function of x. Okay, so this is in the standard form, where we can see the value for p is what? 1 upon 1 plus x square, and value for q is e to the power minus tan inverse of x upon 1 plus x square. Okay, so once you will get the value for p and q, you can find its integrating factor. Okay, this integrating factor I will say it as capital I, which is equal to e to the power integration p dx. Okay, so which is equal to integration p. What is p? P is 1 upon 1 plus x square dx. Okay, and this is equal to e to the power the integration of 1 upon 1 plus x square with respect to x. Okay, and its integration is nothing but e to the power tan inverse of x. So we got the integrating factor, so we can find its solution. Therefore the solution is given by how the solution is given? Y into integrating factor equal to integrating factor into q dx plus c. Okay, so y into integrating factor is e to the power tan inverse of x is equal to integrating factor is e to the power tan inverse x into q. What is q? Q is known to us, that is e to the power minus tan inverse x upon 1 plus x square dx plus c. Okay, now this e has here the power is positive and here the power is negative, so both will get cancelled. Okay, so what remains? This will be integration 1 upon 1 plus x square dx plus c, which is equal to integration of 1 upon 1 plus x square is nothing but tan inverse of x plus c. So this will be our final solution, that is y into e to the power tan inverse of x equal to tan inverse x plus c, and that is our final solution. Okay, now if you'll observe this next example, you can clearly see, and if you'll compare this with our standard equation, which is linear in y, that is dy by dx, p into y is equal to q. Okay, where if you'll compare this, where the value for p is nothing but cot x and value for q is nothing but cos x. Okay, now, and which are functions of x alone. Okay, so this is linear in y, so given differential equation is linear in y. Okay, now once it is linear in y, we will find its integrating factor, and that integrating factor is suppose I, which will be e to the power p dx. Okay, so this will be e to the power integration p is cot x dx. Okay, and this is equal to e to the power integration of cot x is nothing but cos x by sin x, so this will be log of sin x. Okay, so integration of cot x is log of sin x. Okay, and by some rule, logarithmic rule, this will be equal to sin of x. Okay, what rule I have used here? The rule is what? E to the power log of anything. Suppose I will take this as a, its value will be equal to a. So e to the power log of sin x. Okay, so what will be its value? Only sin x. Okay, so finally, once you will get the integrating factor, you can find its solution. Okay, and its solution will be given by y into integrating factor equal to integration q into integrating factor dx plus c. Okay, now put the value y into integrating factor is sin x equal to integration q is cos x into integrating factor is sin x dx plus c. Okay, now we can solve this integration. Okay, we know one term. Okay, you can solve this integration by substitution also, and also by using trigonometric identities. Okay, now what trigonometric identity we will use here. Okay, so we know one formula for sin 2x. Okay, and this sin 2x is nothing but 2 sin x into cos x. Okay, so we have sin x and cos x, but we don't have this 2. So multiply and divide this equation by 2. So this will be 1 by 2 integration 2 sin x into cos x dx. Okay, plus c. Okay, so this will be equal to 1 by 2, and this term is nothing but sin 2x. Okay, this will be sin 2x dx plus c. This is equal to 1 by 2 Now we know the integration of sin x is nothing but minus cos 2x upon 2, okay, plus c. Okay, so finally what will be our answer? Answer will be this 1 by 2 into 1 by 2 will be minus 1 by 4 into cos 2x plus c, and to the LHS this will be y into sin x. So this is our final answer for the given linear differential equation. Okay, now in the next example, if you will observe this example, this is again linear in y. Okay, because why? Firstly, convert this to the standard form, means this coefficient of this dy by dx should be equal to 1. So divide this whole equation, divide equation by the coefficient of dy by dx, that is x plus 1. So what we will get? This will be dy by dx minus 1 upon x plus 1 into y equal to e to the power x into x plus 1 square upon x plus 1. Okay, so again this factor will get cancelled. Okay, so finally what remains? This is equal to e to the power x into x plus 1. Okay, so if we'll comparing with our standard linear differential equation. What is standard linear differential equation? In y, dy by dx plus p into y equal to q. Now we can see here the value for p is minus 1 upon x plus 1, and value for q is nothing but e to the power x into x plus 1. Okay, now we can find its solution firstly by finding the integrating factor. So integrating factor is, suppose capital I, which is e to the power integration p dx, which is e to the power integration minus 1 upon x plus 1 dx. Okay, and integration of 1 upon x plus 1 is what? Log of x plus 1 and the minus sign as it is. Okay, now which is equal to, this is equal to, by logarithmic rule, this will be log of x plus 1 e to the power log of x plus 1 to the power minus 1. Okay, and again by the same process, you know, e to the power log of a is nothing but a. Okay, so our final answer for this integrating factor, that is I, will be equal to x plus 1 to the power minus 1, that is 1 upon x plus 1. Okay, it is to the power minus 1, so it will come down to denominator as a x plus 1 to the power 1. Okay, so finally we can find its solution. Okay, and its solution will be equal to y into integrating factor equal to integrating factor into q dx plus c. Okay, so this is equal to integrating factor is 1 upon x plus 1 into q is e to the power x into x plus 1 dx plus c. So again this x plus 1 will get cancelled with this x plus 1. So what remains? This is equal to integration e to the power x dx plus c, and integration of e raised to x is e raised to x plus c, and to the LHS this will be y into integrating factor is x plus 1 to the power minus 1. So finally we can write its solution, that will be y upon x plus 1 equal to e to the power x plus c. Okay, we will see the next example. Okay, in this example again clearly it is a linear differential equation in y. So if you will compare this to our standard linear differential equation dy by dx plus p into y equal to q, you can see the value for p is cot x and value for q is cosec x. Okay, once you will get the values for p and q, you can find its integrating factor. Okay, and that is given by capital I, which is e to the power integration p dx, which is e to the power integration cot x dx. Okay, which is equal to e to the power log of sin x. Integration of cot x is log sin x, and this is again equal to sin x. So we got the value for this capital I, that is integrating factor, which is sin x. Now we can find its solution. So its solution will be given by y into integrating factor equal to integrating factor into q into dx plus c. So this is equal to integration sin x into q is cosec x dx plus c. So this is sin x into cosec x is nothing but 1 upon sin x dx plus c. So sin x and sin x cancels. What remains? Only dx plus c. Dx plus c, and integration of dx is x plus c. So finally we will get the answer as y into integrating factor is sin x is equal to x plus c. Okay, and that will be our final answer. Now if you observe the next example, in this example clearly the y having the degree 1 everywhere, so it is linear in y, so convert it to the standard form. So divide this whole equation by coefficient of dy by dx, divide by cos x to whole equation. Okay, so what we will get? We will get this as a dy by dx plus 2 sin x upon cos x, okay, into y equal to sin 2x. Okay, now I can write this again as dy by dx is equal to 2 sin x by cos x is nothing but tan x into y equal to sin 2x. Okay, now once you will write it in the standard form, you can find or you can compare this with our standard equation dy by dx plus p into y equal to q, where this p is nothing but 2 tan x and this q is nothing but sin 2x. Okay, so we can find now its integrating factor. So integrating factor, that is I, is equal to e to the power integration p dx, which is e to the power integration 2 tan x dx, which is e to the power integration tan x dx, and integration of this will be equal to e to the power 2 integration of tan x is nothing but log of cos x. Okay, so this is again equal to e to the power log of cos x square. Okay, so finally what we get, what remains here, this is equal to cos x square, which is nothing but cos square x. Okay, so we get the integrating factor I is equal to cos square x. So finally we can find its solution. Its solution is given by, how the solution is given, y into integrating factor equal to integrating factor into q dx plus c, which is equal to integrating factor is cos square x into sin q is sin 2x. Okay, see here we need to divide this by cos x also. Okay, so this will be sin 2x by cos x, this will be sin 2x by cos x. So this will be sin 2x by cos x dx plus c. Now this cos x cancels this cos x. Okay, so what remains? Integration cos x into sin 2x. Okay, sin 2x, I can write sin 2x as 2 sin x cos x dx plus c. Okay, so which is equal to 2 is constant, I can take it out. Okay, so what remains here? Sin x into cos square x dx plus c. Okay, now to solve this integration, its LHS is what? Y into integrating factor. Integrating factor is cos square x. Now to solve this integration, we need to use some substitution to solve this integration. Okay, and what will be the substitution? Substitution will be put cos x is equal to t. Okay, so to solve this integration we need to substitute. So I will put the value for cos x is equal to, suppose, t. Therefore cos x is t. This means minus sin x into dx will be equal to dt. Means what? Sin x dx is equal to minus dt. Okay, so we need to use all this substitution. Means what? We need to put this cos x is equal to t and sin x dx is equal to dt. So see what we get finally, y into cos square x equal to 2 times integration. Now this sin x dx is nothing but minus dt, okay, and cos square x is nothing but cos x into cos x, okay, or cos x whole square. So that will be, this will be value equal to t square, okay. So this will be equal to minus 2 integration t square dt, which is equal to minus 2 integration of t square is t cube by 3 plus c, okay, this is plus c, okay. So this will be minus 2 by 3 and resubstitute value for t is cos x, so this will be cos x to the power 3 plus c. So finally we get the answer as y into cos square x equal to minus 2 by 3 into cos cube x plus c. This is our final answer, okay. Now if you observe this example, this is clearly linear in y, okay. So if you compare, or if you try to convert this to the standard one, we need to divide this whole equation by the coefficient of dy by dx, that is x cos x. So what we will get, this will be dy by dx plus this will be x sin x plus cos x upon x cos x, x sin x plus cos x upon x cos x into y is equal to 1 upon x cos x, 1 upon x cos x, okay. Now to get the integration, to find the integrating factor, firstly, okay, if we will compare this with standard one, what we will get, dy by dx plus p into y equal to q, where p is equal to x sin x plus cos x upon x cos x, okay, and this q is equal to 1 upon x cos x, okay. Therefore the integrating factor is equal to integration e to the power p dx, okay. So this will be equal to e to the power integration x sin x plus cos x upon x cos x dx, okay. So firstly I will simplify this term, x sin x plus cos x upon x cos x here, okay. What is this term? What is this p? P is x sin x plus cos x upon x cos x, okay. So divide every term by x cos x, this will be x sin x upon x cos x plus cos x upon x cos x, okay. So this, in this case x will get cancelled, okay, and here the cos x will get cancelled. So what remains here, sin x by cos x is tan x plus what remains here, 1 by x, okay. So we get the value for p equal to 1 by x. So finally we can find this integrating factor equal to e to the power integration p dx, and value for p is nothing but tan x plus 1 by x dx, okay. So this is equal to e to the power, now integration of tan x is log cos x, integration of this 1 by x is nothing but log x, okay. Now you know log a plus log b is log of a into b, so this will be log of cos x into x, okay. So what remains, we have seen this identity, this will be equal to only cos x into x, which is nothing but x into cos x, okay. So we got the integrating factor. So finally we can find its solution, okay, and its solution will be given by y into integrating factor equal to integration integrating factor into q dx plus c, which is equal to integration integrating factor y into integrating factor is x into cos x, integrating factor is x into cos x, and q is 1 upon x cos x dx plus c, okay. So this cos x cancels, so what remains, integration dx only plus c, which is equal to x plus c. So this will be y into x cos x is equal to x plus c, and this is the final solution, okay. Now in this example, again this is clearly linear differential equation in y. So comparing this with our standard one, that is dy by dx plus p into y equal to q, where the value for p is 2x and value for q is e to the power minus x square. Okay, therefore we can find its integrating factor, which is I is equal to e to the power integration p dx is equal to e to the power integration p is 2x dx. Okay, so e to the power 2 will be out, integration of x dx, so this is e to the power 2, integration of x is x square by 2. Okay, this 2 cancels, so what remains? E to the power x square. So we got this integrating factor I, so we can find its solution. So its solution will be given by y into integrating factor equal to integrating factor into q dx plus c. Okay, y into integrating factor is e to the power x square equal to integrating factor is e to the power x square into q, that is e raised to minus x square dx plus c. Now here the power is positive and here it is negative, so both will get cancelled, equal to 1. So integration dx plus c, and integration of dx is x plus c. This will be y into e to the power x square. So this is how we will get the solution for it. Okay, now next example, we have to find the solution for this given linear differential equation. Clearly it is linear in y, and also to find what will happen when y of 0 is equal to minus 1. So firstly, by our usual method, we will try to find its solution. So if we compare this with our general linear differential equation in y, this will be dy by dx plus p into y is equal to q, where this p, the value is minus 1 here. The coefficient of y is minus 1, so p will be minus 1 and q will be 3 into e to the power minus 2t. Okay, therefore we can find its integrating factor, which is I is equal to integration e to the power integration p dx, which is equal to e to the power integration p is minus 1 dx. So this will be equal to, now see this, in this case the dependent variable is given to be this is t, means this should be equal to t. Okay, so there is some mistake in the example. Okay, this should be equal to t. Why we are thinking of this? Because we need to take the independent variable here also. Okay, so if p is in terms of t, if q is in terms of t, then p should be in terms of t, or integrating factor should be in terms of t. So this value should be equal to, or this independent variable should be equal to t. Okay, so I will change it. This is equal to t, this is equal to t. So integration of minus 1 with respect to t is e to the power minus t. So this is our integrating factor. Okay, now once you will get the integrating factor, you can find its solution. Okay, so its solution will be given as y into integrating factor equal to integrating factor into q dt. Okay, here also we need to change the independent variable dt plus c. Okay, so put the value y into integrating factor is e to the power minus t equal to integrating factor is e to the power minus t into q is 3 into e to the power minus 2t dt plus c. Okay, so this 3 is constant. What remains here? E to the power minus t minus 2t, that will be minus 3t dt plus c, which is 3 into e to the power integration of minus 3t is integration minus that is e raised to minus 3t upon minus 3 plus c. So finally 3 will get cancelled. What remains? Minus e to the power minus 3t plus c. So finally we will get the solution as y into integrating factor, that is e to the power minus t equal to minus e raised to minus 3t plus c. So this is our solution. But what they are said, what will happen when y of 0 is equal to 1? Okay, y of 0 equal to 1 means what? When what will be y of t in, if in the y of t, if you will put t equal to 0, this will become y of 0. Okay, so whatever we have in this solution, okay, this is our solution. I will take it to the next page. Okay, so in this given solution, whatever solution we have got, okay, here y is what? Y is a function of t, so this will be y of t into e to the power minus t equal to minus e raised to minus 3t plus c. Okay, so what they are given y of 0 is equal to minus 1. Okay, means what? In this equation I will consider this as star, so put t equal to 0 because y of 0 is given. Okay, put t equal to 0 in equation star. Okay, so this term will be, put t equal to 0, so that will be y of 0, put t equal to 0, so this will be e to the power 0 minus e to the power 0 plus c. Okay, and we have given the value for this y of 0, and that value is equal to given minus 1. E to the power 0 is 1. Okay, minus e to the power 0 is 1, so this will be minus 1. Okay, plus c, so this is what minus 1 is equal to minus 1 plus c. So minus 1 will get cancelled. What we get? We get the value for c is equal to 0. So finally we will get our solution by putting c equal to 0. That will be y into e to the power minus t equal to minus e raised to minus 3t plus 0. Put value for c equal to 0 by this term. Okay, so what will be our solution? E to the power minus t equal to minus e raised to minus 3t. Okay, you can simplify this. This will be y equal to minus e raised to minus 3t upon, take this term to the denominator of this will be e raised to minus t, which is minus e raised to minus 3t into e to the power minus t will go up as plus t. So this is minus e raised to minus 3 plus 1 is minus 2t. So finally we will get the value for y, which is our solution, minus e raised to minus 2t, and this is the final solution. Okay, and this is how we solve the linear differential equation, which may be y, which may be linear in y, or it may be linear in x. Thank you.